The truth about black holes. Black holes are among the strangest things in the universe. Objects that defy everything we know about physics. They bend space, twist time, and challenge the very limits of our understanding. But where do they come from? And what really happens if you fall into one? Stars, those brilliant engines of light, are made mostly of hydrogen. Under the crushing force of their own gravity, they fuse hydrogen into helium, releasing enormous amounts of energy. This energy pushes outward, perfectly balancing the inward pull of gravity. As long as this balance exists, the star lives in harmony. But massive stars, those much larger than our sun, burn hotter and faster. When they begin fusing heavier elements, they eventually reach iron, and that's where the story changes. Iron fusion doesn't release energy, it consumes it. The star's core suddenly loses balance. In a fraction of a second, gravity wins. The core collapses at nearly a quarter of the speed of light. A massive explosion, a supernova, rips through space, scattering heavy elements across the universe. But deep inside, something terrifying is born, a black hole. If you could look at a black hole, you'd see a perfect sphere of darkness. The event horizon. It's the boundary beyond which nothing, not even light, can escape. To leave, you'd need to travel faster than light, which is impossible. But what lies beyond that boundary, the true heart of a black hole, is something called a singularity, a point where density becomes infinite, where the laws of physics break down. We simply don't know what it is. It's like dividing by zero. Reality itself stops making sense. And no, black holes don't suck things like cosmic vacuums. If our sun were suddenly replaced by a black hole of equal mass, Earth would keep orbiting just fine, though it would quickly freeze in darkness. Now imagine you're falling toward one. From the outside, you'd appear to slow down as you approach the event horizon, time itself stretching infinitely. You'd turn red, then fade, frozen in time. But from your own point of view, you'd see the universe race ahead, as if watching time fast forward toward eternity. Inside, one of two fates awaits you. One, you might experience spaghettification, where gravity's pull on your feet is millions of times stronger than on your head, stretching you into a long, thin stream of atoms. Two, or according to another theory, you'd hit a firewall, a wall of energy so intense that it destroys you instantly. Neither fate is particularly pleasant. Black holes come in many sizes. Some are small, just a few times the mass of our sun. Others are supermassive, sitting at the centers of galaxies, millions or even billions of times heavier. The largest known black hole, TON 618, has a mass over 40 billion suns and a diameter more than 200 billion kilometers, about 47 times the distance between the sun and Pluto. But even black holes aren't forever. Thanks to Hawking radiation, they slowly evaporate. Empty space is full of virtual particles popping in and out of existence. Near a black hole, one particle may fall in while the other escapes. And with each escape, the black hole loses a tiny bit of energy. Over unimaginable timescales, trillions of years, even the biggest black holes will fade away, leaving nothing behind. When the last one dies, the universe will be silent, dark, and empty. But that's not the end of the story. Black holes might still hold secrets, clues about time, space, and even the origin of our universe. That's a mystery for another video. If you love exploring the unknown, from the edge of space to the limits of science, make sure to follow this channel. Your curiosity keeps the universe alive. Subscribe and let's journey through the cosmos together.